When you think of hydraulic system maintenance, what's the first thing that comes to mind? Most likely it's replacing filters, servicing reservoirs, or changing components. Well, the hydraulic system's pieces and parts that need the most attention aren't components and filters. They're lines, B-nuts, O-rings, and seals. We'll break down 100 hydraulic system problems that Continental Airlines experienced with its A320 fleet. 16 of the problems will have to do with indicators and pressure-operated switches. 11 problems will be caused by system servicing difficulties. 11 more of them will be component failures caused by mechanical breakage. 24 of them will be component failures caused by internal leakage. The remaining 48 problems are because of leaking hydraulic tubes, B-nuts, O-ring packings, and other types of seals. That means that 48 of every 100 hydraulic system problems are caused by a simple plumbing failure. However, these problems cause the greatest number of flight delays and cancellations. These simple plumbing problems can also be real hard to fix if you don't know the basic hydraulic plumbing rules. If you don't work carefully and follow these rules, your work may be the cause of the next hydraulic leak that delays or cancels a flight. Let's look at these basic hydraulic plumbing rules. Always work clean in cap-open lines. Contamination that gets into a system or collects on sealing surfaces can cause leaks, internal and external. Hydraulic fluid itself is a contaminant. It can eat paint and decals. When hydraulic fluid is allowed to penetrate a composite structure, it will attack the core material and reduce it to mush. Once a composite assembly has been attacked, its structural integrity will be lost. To avoid damage caused by twisting, tearing, and chipping, always lubricate O-ring packings, seals, backup rings, and fitting threads with hydraulic fluid before assembly. When assembling hydraulic system fittings, be sure that seals and backup rings are properly positioned before torquing the connection. When installing an elbow fitting into a component, be sure that all the threads are completely screwed into the boss. This is to make sure that the O-ring packing rides in the undercut and not on the threads. To prevent an elbow fitting from turning while its lock nut is being torqued, hold it with a second wrench. To make a stress-free installation, be sure that all elbow to pipe connections are correctly aligned before torquing the B-nuts. Do not use pointed, sharp-edged, or steel tools to remove or install O-ring packing, backup rings, and seals. Damage may occur. Never reinstall used O-ring packings or seals. Once they've been compressed, they will never regain their original shape again. It's okay to reinstall backup rings and washers again if you are sure that they have not been damaged. Remember this: if you have any doubt, always install new ones. Before torquing a B-nut, be sure that the tube fits squarely into the fitting. Never force or bend a tube to make it fit. Metal tubes don't stretch. If a piece seems shorter upon reinstallation or after a component change, something is wrong. Stop, think, and investigate the problem before you proceed. Make sure that tubes are not forced into clamps or line blocks. A stressed installation will lead to a cracked tube at the nearest fitting or B-nut, and you can bet it won't be long before it happens. If clamps or line blocks are removed so a tube or component can be replaced, be sure that they are reinstalled again. Tubes that are not properly supported will vibrate. Vibration is the greatest enemy of a hydraulic system. It causes tubes to crack and connections at fittings to loosen up and leak. When repairs are finished, always bleed the system and leak check your work. We, the mechanics, have control of torquing. The lack of proper torquing is the single greatest cause of leaks. Those calibrated elbows are notorious for being out of calibration. Use a torque wrench. All right, that's the basic rules. They can keep you out of trouble. Airbus has a booklet available called Hydraulic Systems Working Practices. It contains information from the Airbus Maintenance Manual that will help you maintain leak-free hydraulic systems in your aircraft. The subjects covered are simplified schematics, general tips to prevent leaks, pipe connection torque values, and precautions to avoid line chafing. Let's take a closer look. We'll start with torquing. As we've said, when it comes to preventing hydraulic leaks, proper torquing is important. You simply can't get the correct torque without using a torque wrench. If, by chance, you get the correct torque without a torque wrench, you just got lucky, and luck has no part in our business. Every time you torque a B-nut, union, or fitting, the first thing you must ask yourself is, what kind of material is this tube made from, and what's its diameter? The material is usually steel or aluminum. When the material is steel, it will either be thin-walled stainless, it's called cress, or titanium. Aluminum is also called light alloy. With this information, the correct torque is at your fingertips. Look it up in the maintenance manual. You will always find it in Chapter 20, Section 23, Subsection 12. The tables or charts are laid out according to the pipe diameter and the type of material used to manufacture the pipe. Okay, you've got the right torque value. Back at the airplane, you discover that you can't reach the B-nut with just a torque wrench and crow's foot. You need an extension. When you add the extension, the lever length changes. That's the distance between the center of the handle and the center of the crow's foot. That means your torque value must also change because of the increased leverage. Do you remember the formula T2 equals T1 times A over A plus B? With it, you can compute the new torque. Let's do an example problem using the formula. Our tubing diameter is 9.52 millimeters, and it's made from aluminum, light alloy. The chart states that the torque range is 1.8 to 2.0. If we were working in pounds rather than metrics, we would use the numbers in parentheses. Okay, T1 is the required torque at the union. It's 2.0, which is the upper limit of our acceptable torque range. A is the lever length of the torque wrench. It's 300 millimeters. B is the lever length of the extension. It's 100 millimeters. Now it's only simple math. 2.0 times 300 millimeters equals 600. 300 millimeters plus 100 millimeters equals 400. 600 divided by 400 equals 1.5. So, T2, torque reading at the wrench dial, equals 1.5, our new value. Let's say you were working with a torque wrench that reads in inch-pounds of torque. Then, if T1 equals 14 foot-pounds of torque, T2 will equal 10.5 foot-pounds. One more math step is required to convert the 10.5 foot-pound reading into an inch-pound reading. Multiply 10.5 times 12 inches. The new reading will be 126 inch-pounds. If you don't use a torque wrench, one of two things will happen. If the tubing is steel, the B-nut will be under-torqued. If the tubing is aluminum, it will be over-torqued. Studies by the manufacturers and the airlines have proven this to be true. Under-torqued steel leaks, but over-torqued aluminum cracks, compresses, and fails. Look the torque up in the Airbus maintenance manual. It's the only way a professional works. The Hydraulic Systems Working Practices booklet also has information in it about torquing hydraulic tubes and torque values. Remember, this booklet is only a quick reference guide and is not regularly updated. The Airbus maintenance manual is always the final reference document. If a B-nut or a connection at a component is found to be leaking, it must be disconnected and inspected for damage. The tube may be cracked or worn because of vibration. Whenever a connection with an O-ring packing is disconnected, always replace it. O-rings compress and harden with age. If you should ever come across a leather backup ring, be sure you replace it with an equivalent one made of Teflon. If a tool is necessary to remove or install a seal, use one made of brass or a similar material. Remember, hard, sharp-edged tools can damage seals and sealing surfaces. Alignment of hydraulic tubes. You'd think that was automatic. When an airplane is designed, the component positions are determined and the tubing is formed to make all the connections. Unfortunately, tubing cannot always be formed to make a connection. The turn may be too tight, or structure may be in the way. When this happens, an elbow fitting must be installed, and we are responsible for its alignment. You can find elbows on components, at bulkheads, and in other tight locations. When installing an elbow, be sure you screw it in until it's at the proper depth. If it makes a connection between a tube and a component, remember, the O-ring must ride in the undercut designed for that purpose. Once you have gotten the proper depth, turn the elbow until it aligns with the tube. Now tighten the B-nut with your fingers. Hold the elbow with a wrench and torque the lock nut. After that, check the alignment with the tube by turning the B-nut with your fingers. If it doesn't bind, you've got it right. Now torque the B-nut and you'll have a properly torqued, stress-free connection. Stress. To create a stress-free tubing installation, there are 4 steps. Position the tube with the clamps loose. This allows the tube and the fitting to align with each other. Align the tube and the fitting by hand and bottom the tube in the fitting. Remember to smear the threads with hydraulic fluid. Hold the tube in alignment and tighten the B-nut by hand until it contacts the sleeve shoulder. If you can't screw the B-nut down by hand, it's not properly aligned. Now, torque the B-nut to the proper torque as shown in Chapter 20 of the Airbus Maintenance Manual. Remember to hold the union with a wrench while you torque the B-nut. One last thought about stress. If a B-nut is used to stretch the tubing, the connection will not be stress-free. Now we know that tubing can't really stretch, so the stress will most likely cause a leak or a blowout. Always be on the lookout for the risk of chafing. If it looks like a hydraulic tube could come into contact with structure or another hydraulic tube, use nylon ties and flexible blocks and tie straps to hold the tubing in its correct position. Be careful and don't add stress to the hydraulic tube that's being tied down. Chapter 20, Section 23, Subsection 14 of the Airbus Maintenance Manual explains the correct way to use nylon ties, flexible blocks, and tie wrap straps. Their use is also covered in the Hydraulic Systems Working Practices booklet in Section 4, Precautions to Avoid Line Chafing. After working on a hydraulic system, the reconnected tubes and fittings must be leak checked. Before actually doing the check, the work area must be clean and dry. If you find a leak, depressurize the system. Disconnect the tube and inspect the connection for damage. After the inspection is completed, torque the connection to the correct torque value. When the work is finished, the system must be bled. Any time a tube is disconnected, fluid is lost and air replaces it. A320 hydraulic systems are a closed-loop design. The fluid leaves the reservoir, carries the hydraulic energy to the components that do the work, and then returns to the reservoir. The system, through normal operation, will bleed itself. The only components on the aircraft that will not self-bleed are the brakes. Good maintenance practices tell us to accelerate the bleeding process and remove any trapped air before the airplane flies. To complete the process, you power up the system's pumps, electric or engine-driven, and operate that part of the system that was worked on. The trapped air will move to the reservoir and be vented overboard. Be sure to check the reservoir fluid level after the hydraulic system is bled. It may need to be serviced. All right, that's it. But I want to say one more time that it's important to use a torque wrench and to look up the correct torque value in Chapter 20 of the Airbus Maintenance Manual. Work smart. Be smart. You're a professional.